This lecture is part of a course entitled Complete Guide for Water Treatment Plant Design. You can find the link in the description box.
After studying the rapid sand filtration, now we will study the second method of filtration, which is the slow sand filtration. We will start by an overview. A slow sand filter requires little to no pretreatment. Actually, if our raw water turbidity is less than 50 NTU, so the initial water's turbidity that is being taken from the lake, reservoir, or river has a turbidity less than 50 NTU, we don't really need a pre-treatment, only we need a basic screening so that a coarse or large material do not enter in the slow sand filter, and this might clog actually the pipes of this filter. So we don't really need coagulation and flocculation, and even we don't need a pre-sedimentation tank. So a slow sand filter will be able alone to highly treat the water, and we would get excellent results that are able to meet the national and international standards. After the filtration, we need also a basic disinfection, because a slow sand filter is also able to highly disinfect the water. We will see this later on. So a simple chlorination for the storage, and this is essential also when distributing the water. So a basic chlorination, then the water is ready to be distributed to the community. Now, if the water's turbidity is higher than 50 NTU, we can just add a clarification tank, so a pre-treatment with a clarification tank, which is a simple sedimentation tank. Also, no need for coagulation and flocculation, no need for any type of chemical. So screening, clarification, slow sand filtration, then basic chlorination, and the water is ready. So the slow sand filter is actually an excellent method to remove suspended particles as well as pathogenic organisms. And this is the major difference, let us say, between this type of filtration and the rapid sand filtration. Why we have the removal of pathogens like bacteria, viruses, protozoa? Because we have a biological activity. We will see what triggers this biological activity later on. And also we have physical activity or physical removal, because we have the presence of a media, a sand media, that will trap the suspended solids. So as we have already said, that a sand media, actually it acts like a sieve. So it will trap anything that is higher than its opening. This type of filtration is best suited for raw waters of low turbidity. So if your initial water, or if our initial water has a low turbidity, anything less than 50, if it is less than 25 NTU, we will get actually excellent results. Also, this type of filtration do not require coagulation and flocculation as pre-treatment. So no need for chemicals and no need for heavy mechanical equipment. We have practically no electrical consumption throughout the whole process. We only need pumps if we don't really have gravity, just to pump the water into the water storage tank. Now, if the water is highly turbid, so anything higher than 50 NTU, you have to use pre-treatment. This can be sedimentation, because a high turbidity will clog the filter quickly, and also you might face some problems with the quality, the effluent quality. You might not be able to meet the standards and regulations. Now, the biggest con, or the biggest disadvantage of a slow sand filter is the large footprint. It requires a big volume compared to a rapid sand filter. Why it needs this huge area compared to a rapid sand filter? Because the rate of filtration is between 3 to 8 cubic meters per meter square per day. So just try to imagine this number. So each meter square is only able to to treat 3 to 8 meter cube of water, while for the rapid sand filter it was 100 to 200. So notice the huge difference. So this is why we need a very big area, so a huge area compared to a rapid sand filter, so we are able to treat the daily demand and the required daily flow. And this is why actually a rapid sand filtration is more popular, or it is way more used than a slow sand filter. In the slide we will learn how a slow sand filter operates. You will notice that there is a quite difference between a rapid sand filter and a slow sand filter, especially in terms of operation and maintenance. So let's start describing the slow sand filtration process. So the water will actually enter through a pipe, and this pipe is equipped by a sluice valve. We have also many valves in a slow sand filtration that are going to control the operation of this filter. So the water will enter and will flow into this basin. This is actually a rectangular basin. Okay, slow sand filters are actually rectangular basins, very long rectangular basins, okay, that are placed one beside the other. Okay, we have many basins and they have all common walls, as we have mentioned previously. They are mainly made of concrete and they are filled with some media. They require a very big volume. I will erase this drawing. So once the water enters into this basin is actually filled with media. It is filled with a sand layer and a gravel layer. We have already said that the gravel layer is not a filtering media, it is only a supporting media. It supports the sand, and also it will protect the perforations in the drainage pipe from sand media infiltration. So we don't really want this media to enter into the drainage perforations, otherwise we will face some clogging problems. So this is the main function of the gravel. The sand media has actually very small diameter compared to a rapid sand filtration. So this is actually the first difference. So the sand media has 0.1 to 0.3 millimeters diameter, and if we compare it to a rapid sand filter, it was 0.45 to 0.55, and this implies actually slow filtration rates. So these small openings will allow for slower filtration rate, and this will actually help to remove more particles and finer particles compared to the rapid sand filtration. Above this sand layer, we will have the accumulation of water. This is what we call as supernatant water, and the depth of this water is actually 1.2 to 1.5 meters. What controls this depth? It is actually the float valve. So whenever we reach the 1.5 meters, this float valve will close the sluice valve. So this will close and the water will no longer enter. So this is the upper limit of our supernatant water that will create some pressure. This filter will not be actually backwashed. We don't have backwashing in order to clean the media. And this will imply the formation of a dirty skin, or what is more commonly known as the schmutzdecke. This schmutzdecke layer will be formed at the top of the sand layer, and maybe from its name it sounds something bad, dirty skin, a dirty layer, but actually this is the bulk of the treatment. This is where we have the biological activity due and thanks to this dirty skin layer. This layer is actually formed of a good type of bacteria. We will see later on the components of this dirty skin, and these components are actually hungry and they are starved and they need food, and they are going to eat the organic matters that are in this water. So whenever the supernatant water is in contact with this dirty skin, we will have biological activity, and this will allow the high reduction of organic matters and also of pathogens, of viruses, of bad bacteria, of protozoa. This dirty skin has a major importance. And whenever the water crosses this layer, so we have the biological activity there, and then we have the physical removal in the sand media. We have the removal actually of the suspended solids that will be trapped within this media. When the water is treated, it will leave through the drainage, through those perforated pipes. We have the same kind of perforated pipes like the rapid sand filter. And then the water will move to this water sump. So with the water sump. This water sump is actually equipped with an effluent pipe. So the water will flow in this sump, and then it will enter into this effluent pipe and it will leave. This effluent pipe is equipped with a telescopic pipe. So we have a part here, so I will remove this. So we have this upper part, as you can see, we have this upper part that is equipped with a float. This is a movable part. It moves with the water's level. And this water's level will indicate the head loss. And this head loss will increase as this schmutzdecke layer, this dirty skin, is going to increase in depth. So this throughout the time, the dirty skin that has an ideal depth of 3 to 5 centimeters. So the depth will start increasing and the head loss will increase. So the water level in the sump will start decreasing. So when it reaches this level, so this level that is the critical level, the float will close the pipe. Okay, so I will erase this. So this float will reach the top of the pipe and it will close it. So this is where we will know that we need to clean our slow sand filter. Whenever the water stops flowing in this pipe, the effluent pipe, we know that it needs to be cleaned. And how we clean it? So we need a manual cleaning. Okay, no backwashing, no blowers, no air diffusing, no pumps, nothing, no mechanical equipment, no energy consumption at all. And this consists of scraping the dirty layer. So the operator or the worker is going to close the sluice valve. He is going to close V1 and he will open V3, the waste pipe. So the water will be drained. We will get rid of the water within the filter, and of course V2 will be closed, and he will remove manually this layer, the dirty skin layer. He will remove it manually. Then he is going to open V1, the water will enter, but we will keep V2 closing. We will not going to collect this water. Instead, we will waste it. We will throw it, or we will get it back to its source. And we will wait a few days till we have the reformation of the schmutzdecke layer. We need at least 3 to 5 centimeters of dirty skin layer to have the biological activity. Otherwise, we cannot send our effluent to the reservoir. So this needs a few days. Then after the formation of the schmutzdecke, we will close V3 and we will reopen V2. So this is practically how a slow sand filter works. We will be detailing some components in the next few slides. To quickly summarize what we have already seen, so slow sand filters, they are gravity driven, so the water is being filtered through the media by gravity. We don't need any water pumps or pumping or high pressure. They can be distinguished from rapid filters by their lower filter velocities, finer filter material, and these will imply a way higher volume. Notice how big these slow sand filters are, and the fact that they are not designed for backwashing. Okay, we don't need backwashing. When do we use slow sand filters? Actually, rapid sand filters, they don't have any limitations. They can be used in any water treatment plant and in mostly all the cases. It is not the same for slow sand filters. We have limitations. We use the slow sand filter when land, labor, and filter sand are available at low cost. Especially we have the constraint of land. If the land is small, or if it is very expensive, just discard the idea of slow sand filter. Also, we need labor for scrapping, for cleaning, and also filter sand. Notice it requires a lot of sand, of media. So if the sand is not available at low cost, also forget about the slow sand filter. It is not feasible. Just choose directly the rapid sand filtration. Also, it is ideal to be used when chemicals and equipment are difficult to procure. So when we say chemicals, it is mostly the chemicals used for coagulation and flocculation. Sometimes you cannot find these chemicals easily in the country you are working with. The slow sand filter would be an ideal solution, and also equipment, because rapid sand filtration, they involve backwashing using a blower. For example, we have equipment, we have a blower, we have pumps, we have dosing pumps for the chemicals, and also mixers. We have many mechanical equipment, and these are not easily found in some regions and some countries, especially if you are working in far regions, in villages that are far from the cities, for example. Also, slow sand filters, they are ideal when skilled personnel to operate and maintain are not available locally. A slow sand filter, basically, it needs no expertise, let's say, for its operation and maintenance. We don't really need skilled engineers and skilled operators, unlike the rapid sand filtration and the processes like the coagulation and flocculation that involve strict monitoring. A slow sand filter can work alone, let's say. It requires some basic monitoring, checking the effluent quality every now and then, and make sure that everything is working well. So no need for a skilled personnel. And also, a slow sand filter, it is ideal when the water does not contain high suspended matter or high turbidity. We have already said that if our water is kind of clean and requires little treatment, then a slow sand filter is also an ideal solution and option. We will go through the media quickly. So we have two types of media, as we have said, gravel and sand. The depth of the gravel is 0.3 to 0.6 meter, used as a base material. It provides support for the media. It covers the drainage pipe to protect it from clogging. So we have already explained all these points. And the filter gravel is usually graded from 2.5 to 50 millimeters. So this is the diameter, but we usually use it between 35 to 40 millimeters. The diameter, let's say, it doesn't really matter because this is not a filtering media. Now, concerning the sand media, the depth of this layer is 0.9 to 1.5 meters, but it is actually it has to fill a huge surface area. The length and the width of a slow sand filter, they can reach 50, 60, 70 meters. So we are talking about very big amounts of sand media. The size or the diameter is 0.1 to 0.3 millimeters. So these are very fine particles, and the uniformity coefficient is between 3 to 5. Let's check the efficiency of a slow sand filter. Actually, a slow sand filter is highly effective against bacteria. We have 99% removal of bacteria, and this is impossible if you are using rapid sand filtration. Highly effective against protozoa, viruses, and E. coli. So it plays a role of disinfection. And all these are actually removed thanks to the Schmutz-Deck layer, thanks to the biological activity within this sand filter. Also highly effective against turbidity if our turbidity is low, as we have already said. And this is reduced through the physical filtration in the media, in the sand media, and also highly effective against heavy metals like the zinc, the copper, cadmium, and the lead. Less effective against odor and tastes. To remove odor and taste, we usually use the activated carbon media. And a slow sand filter only accepts sand as media. So if your initial water has odor and taste, we must choose a rapid sand filter with an activated carbon media. Also less effective against iron and manganese when they are in the ionic form, when they are dissolved in water. So these are ions, and also less effective against arsenic. Not effective against salts. Salts, they have one solution, the reverse osmosis, the RO. Okay, no filter, no traditional filter can remove salts. Also not effective against fluoride and the majority of the chemicals. We will go through the advantages and disadvantages quickly. It is simple to design, construct, and operate. This is actually a basin filled with media and some mechanical piping equipment. Something very basic. Little or no pre-treatment required. So only plain sedimentation if we need pre-treatment, and we don't need coagulation at all. No coagulation and flocculation, no chemicals. Also, we don't have any mechanical part, no power-driven mechanical parts. We don't really need electricity to operate a slow sand filter. No necessity for chemicals at all, except for simple or basic chlorination at the end. And we have a high effluent quality, since we are able to remove many types of bacteria, viruses, protozoa, and also reduce the turbidity and the heavy metals. There is also a possibility of application of locally available materials, since we need basic materials and also basic skills with limited technical supervision. We don't really need engineers or highly skilled and experienced operators. No need for backwashing. No wash water is required. Thus, water is saved. We are not throwing any kind of water. Imports of materials and equipment can be almost negligible. So if you have sand media available locally and some basic pipes, then you are doing fine, and no need for energy except for pumping the water into the reservoir, of course, since it cannot go by gravity. Concerning the disadvantages of a slow sand filter, so we have slow filtration rate, and this implies large area of land. It also requires large volume of graded sand, so we need around 50 to 100 times more sand than rapid filters. And this would be a problem in areas where sand is not available locally. So if you want to import the sand media, then this would not be really feasible. Also, cold temperatures, they lower the efficiency of the process due to a decrease in biological activity. Okay, so when we are working in freezing temperatures, this might block the biological activity and the activity of the Schmutzdeck layer. Also, the effluent might have a high turbidity. If our raw water's turbidity, the initial water's turbidity is high, then we will face some problems with our effluent's quality. We would face high turbidity. So always pay attention on the raw water's turbidity if it requires pre-treatment, if it requires sedimentation, for example. Also, we might face algal growth in tropical conditions. These filters are exposed to atmospheric conditions. They are exposed to hot weather, to sun. So this can cause the algae growth, actually, and this might block the filter and cause taste and odor.